What is the meaning of life? How do we fit in this grand universe? We're on a journey, and this is one of the first early steps.
The Kepler spacecraft was sent into orbit by NASA in 2009 to look for distant planets.
The objective of the mission is to find out whether Earth-sized planets are common in the habitable zone of stars like our Sun.
The habitable zone is where a planet is not so close to its sun that water would just boil away, and not so far from its sun that it would only be ice. A place that might support life.
Yes, Venus is Earth-sized. It's very close to the habitable zone. It's hotter than a pizza oven, okay? It's a dry desert. There's no life. And yet it has an atmosphere, it just doesn't have any water.
Kepler is making initial observations of planets in the habitable zone.
Future missions will determine, do they have an atmosphere? If they don't have an atmosphere, it can be exactly the size of the Earth. In the habitable zone, there will be no life.
A photometer is the single scientific instrument on board Kepler.
It doesn't image, it doesn't focus.
It measures only the brightness of the stars.
But it's amazing how much science you can do. That's a pretty powerful piece of information.
The details of the pixel size and their resolution was a commercial CCD, so it wasn't really anything super high quality that was made specifically for Kepler.
We use the biggest array of detectors that had ever been flown.
Kepler was sent into space to point at the Cygnus constellation.
You're looking at the edge of the Milky Way that aren't the stars like our Sun. So every time you get an image, you can image 4.4 million stars. And it takes an image about every 6.3 seconds.
But they're focusing on only about 170,000 of them. Kepler records the images and stores the data before later downlinking it to Earth.
You have to use computer algorithms in order to search through all that data to test all the possible orbital periods and times to first transit and even transit duration.
If Kepler is looking at a star and light coming from it dips, that could mean that a planet is going by. And that change in light is tiny.
In about 1 part in 12,000. So you need to be able to detect this change over 6 or 10 hours or so. But you also want to be able to do that for 3 or 4 years so that you can see these things transiting year after year.
We're doing transit photometry. The only time you get a signal is when the planet crosses directly across the star in your line of sight. Most of the time, you look at the geometry. That doesn't happen.
Because if they're in the habitable zone, one transit could be in the hundreds of days, like Earth. Kepler's data on stars is made available to astronomers on Earth, who help in determining whether a change in light actually signifies the presence of a planet.
We have 4,600 candidates, stars that we believe have planets, but we haven't proved it. We have over 1,000 where we've done the work. We've used the ground-based telescopes to prove it is indeed a planet.
Bill Barucki came from Wisconsin to California in the early 1960s to work at NASA's Ames Research Center.
When he first started working there, he said he was going to change jobs every 5 years, and you see how well that worked.
He and his wife Josephine still live in the same house in Sunnyvale, where they've raised 3 daughters. Science always featured at home.
Bill loves to talk about his work, so yes, I became very educated as far as any phase of space science that he was working in. It's fascinating and exciting.
Get a really good microscope. We'd look at everything under the microscope. You know, if we cut ourselves, we'd look at the blood under the microscope.
We didn't run for a Band-Aid, we ran for a slide.
He taught us how to do everything. We had to learn how to work on cars if we were going to drive. We had boats, different sailboats, little ones, and then they got a trimaran that they fixed up.
We found we were both interested in rockets.
Cell phone coverage up in the mountain.
Bill's childhood friend Gene also came west in the 1960s. Gene remembers Bill talking in the early 1980s about what would later become the Kepler mission.
wouldn't it be nice to know if there were other planets and something about them? He said, how about this? He said, if we just observe the light from one of the stars, and if a planet passes in front of it, it's going to dim that light. And from how long it takes to go around again, we're going to know something about the orbit. I thought to myself, wow, what a simple and beautiful idea.
And not so easily realized, NASA didn't approve the mission for 10 years.
I felt it was so important to mankind's understanding of its place in the universe that it was worth my trying time and time again.
For many years, Bill and his team, and myself included, worked very hard to come up with solutions to every problem that was posed, to come up with an answer to every question about why it couldn't work. And we succeeded and were selected for launch in December of 2001.
But then there were setbacks.
The biggest thing that happened is the budget changed. NASA as an agency didn't have the funding that they thought they would have.
When liftoff of the Delta II rocket with Kepler.
Kepler didn't go into space until 2009. And after about a month, they found
The instrument was performing probably better than we had even expected.
I wrote a paper about Kepler 62. It was my discovery. It has 2 planets in the habitable zone, not just one. That's a pair of my favorite planets.
Kepler is still in space. It met its planet-finding objectives in 2012. The next year, its mission changed when 2 of the 4 reaction wheels that spin to hold the telescope in place failed.
If you only have 2 of them, you can only point correctly in 2 directions. You could point at the star, but the telescope would start rotating.
For the new mission, called K2, Kepler is pointed in a different direction and uses the power of photons from the sun to balance the spacecraft in the absence of a 3rd functioning reaction wheel.
K2 is being operated as a general-purpose observatory. Every target that K2 observes is for the benefit of a guest observer.
After 53 years, is there anything at NASA you think you somehow miss doing?
Probably retiring earlier. I love the research. It's just hard to put up with all the red tape.
In early July, Bill Barucki finished his time as a salaried NASA employee, but isn't finished as a space scientist.
I will be continuing that research as an Ames associate. Life is much more complex than anyone ever expected out there. And it's richer